If you are in your final year of engineering, or you have just graduated, you are probably being told the same thing by everyone. Learn coding. Get into software. And that is fine advice for some people. But there is another field, right next to it, that builds the physical world you live in. It is called industrial automation. In the next few minutes, I will tell you exactly what it is, what the work feels like, what it pays, where it is going, and the parts of it that are genuinely hard. No exaggeration. Just what 15 years inside real plants has taught us. Industrial automation is the engineering of making machines run a factory safely and repeatably without a human standing there turning every valve. It has 4 parts, and every system you will ever touch is some version of these 4. Sensing, where instruments measure temperature, pressure, flow, level and position. Deciding, where a controller called a PLC or ADCS runs the logic thousands of times a second. Acting, where motors, drives, valves and robots physically move the process. And supervising, where SCADA screens let one person watch an entire plant from a single room. This is not a niche. You have already used it today. The car you traveled in was welded and painted by robots on an automated line. The medicine in your cupboard was made in a validated batch reactor with every parameter recorded. The water in your tap passed through an automated treatment plant. The electricity powering this video came through turbine and grid control systems. And the newest demand is in semiconductor fabs, electric vehicle battery plants and data centers, all of which are being built in India right now, and all of which need control engineers. Here is the anatomy of a plant from the ground up. At the bottom are field devices, the eyes and muscles. Above them are the controllers, the PLC or DCS, and this is the heart of the job. Above that sits supervision, the SCADA and HMI screens with their trends and alarms. Then operations, where MES systems record what was made, at what quality, with how much downtime. And at the top, business systems and analytics, where artificial intelligence is now being used to predict failures before they happen. Your career can move up this stack for 30 years and never run out of new ground.
So what does the job actually feel like day to day? It has 4 modes. In design, you read the customer process, select hardware, draw the panel and size the network. In build and test, you write the logic and the screens and prove them on a bench before they ever reach site. In commissioning, you go to the plant, check every single signal, start the machine, and fix what the drawings did not tell you. And in support, you train operators, tune the process, cut downtime, and keep the system secure. Most engineers find they enjoy one of these more than the others, and that becomes their specialization. Which brings us to the 4 careers that live inside this one field. The design engineer, who works with panels, schematics and standards. The commissioning engineer, who travels to sites across India and abroad, and who learns faster than anyone else. The systems integrator, who works with SCADA, MES and databases, and whose job is closest to software. And the newest one, OT cybersecurity, protecting plants from cyber attack. That last one barely existed 10 years ago, and today almost every large tender asks for it. Very few engineers can do it well, which is exactly why it is worth learning. Now the honest question. Why choose this over a pure software job? 3 reasons. First, you build real things. Your logic moves steel, fills bottles and keeps a city supplied with water, and you can stand in front of the machine you programmed. Second, the field is far less crowded. Thousands of graduates compete for the same software roles, but very few can wire a panel, read a process diagram, and debug a live production line. And third, this work is hard to automate away because it needs judgment, hands, and physical presence on site.
Let us talk about money and growth, realistically. In your first 2 years you are a trainee, learning hardware, wiring and the basics of programming and assisting on site. Between 3 and 5 years you become a project or commissioning engineer, owning machines end to end, and this is where both your confidence and your pay rise sharply. From 6 to 10 years you lead engineers, size systems, quote jobs and speak directly to customers. Beyond 10 years you become a manager, an independent consultant, or you start your own integration business, as many in this industry do. And overseas site work, in the Gulf, Southeast Asia and Africa, is common from year 3 and changes earnings substantially. Is the demand going to last? Look at what is being built. Electric vehicle plants, battery gigafactories, semiconductor fabs, solar parks and green hydrogen units, and every single one of them needs a control system. At the same time, thousands of older plants are running 20-year-old controllers whose spare parts are disappearing, and migrating those systems alone will keep engineers busy for a decade. On top of that foundation sit the newer skills, Industry 4.0, data historians, machine learning for predictive maintenance, and cybersecurity. The base you learn now stays valid, and what sits on top of it keeps getting more valuable. Now the part most career videos skip. What is genuinely hard about this work? Site life means travel, plant canteens, heat, dust, and long stretches away from home. The hours can be strange, because shutdowns happen at night and over holidays, since that is the only time a plant can stop. You never stop learning, and if you stop reading for 3 years you will fall behind. And the consequences are real. A mistake can injure someone or cost lakhs of rupees an hour, so discipline and safety are not optional here. If none of that puts you off, you are exactly the kind of person this industry is short of.
Who actually does well in this field? 4 kinds of people. The curious, who open the panel to understand how it works, not just to close the ticket. The methodical, who check loop by loop and signal by signal, because shortcuts taken on site come back as failures at 2 in the morning. The communicators, who can explain a system in plain language to an operator, an electrician, a manager and an auditor. And the calm ones, because when the line is down and everybody is watching, the engineer who stays calm becomes the one nobody wants to lose. If you decide to start, learn things in this order. First, electrical basics, so you can read a wiring diagram and understand contactors, 24-volt control, earthing and protection. Second, instrumentation, the 4 to 20 milliamp loop, thermocouples, and pressure and flow transmitters. Third, PLC programming, ladder logic on any one platform, because the concepts transfer even if the brand changes. Fourth, SCADA and HMI, building screens, alarms, trends and reports properly on one package. And fifth, safety and cybersecurity, which is what separates an engineer from a technician. Here is a 90-day plan that actually works. In the first 4 weeks, learn the fundamentals properly and build the vocabulary, because in an interview the words you use reveal how much you really know. In weeks 5 to 8, do projects. Program a bottling line, a lift, a tank level control, and record videos of them working. In weeks 9 and 10, certify. A safety and a cybersecurity credential make your resume look different from every other fresher applying that day. And in the last 2 weeks, build a one-page portfolio, apply to system integrators and machine builders, and take the first site job you are offered. Site experience compounds faster than anything else.
At Wonderseas Academy, this is all we do. Our industrial automation program covers PLC, SCADA, HMI, drives and panel wiring, hands-on. Our Industrial Safety Essentials course gives you the safety passport that every site asks for. And our Industrial Cybersecurity Essentials course gives you a skill that almost no fresher walks in with. Everything we teach comes out of 15 years of live plant projects, not out of a textbook. Visit lms.wonderseasacademy.com to begin. Whatever you choose to do next, choose something that builds. All the best.